Good morning, students. So, in the last class, we studied about some structures of the valence shell electron pair repulsion. So, now we are going to study the drawback of that VSEPR theory. So, what is the drawback? Listen. So, I told you, of course, it explains the shape of the molecule. It explains the bond angle between them. But it fails to explain. So, whatever the bond I wrote, that is what? Single bond only. I didn't consider any double bond. Even though I consider the double bond, that is taken as only single bond, like CO2 molecule. It is like C double bond O double bond O. Even though this is taken as A, this is taken as B, AB2 type. Understand? So BeCl2. So BeCl. So this is single bond. So this is also AB2 type molecule. But so in these two, of course the molecule is in AB2 and AB2. Here the single bond is there, here the double bond is there. So this VSEPR theory only tells about the lone pair of electron and the bond pair of electron, their bonding. But it fails to explain the formation of a single bond and a double bond. Okay, and at the same time, it fails to explain overlapping of the orbitals. Means, for example, if I take CH4, so this hydrogen has s orbital, this carbon has p orbital, valence shell. CCl4, carbon is also having p orbital, this is also having p orbital. So if means why I am telling p orbital means the last electron, this carbon means 1s2, 2s2, 2p2. The last electron is at where? Is at p orbital. Means here p orbital. This hydrogen is 1s1. So s orbital. This is 1s2, 2s2, 2p6. Sorry, 2p2. This one is 3p5. If you write the configuration, the last electron is in p orbital. Here one is the p orbital, another one is the s orbital. Here one is the p orbital, another one is also p orbital. So this fails to explain. Even here is also single bond, here is also single bond. So it fails to explain the formation of the single bond and overlapping of the atomic orbital. And mainly it contains only the presence of lone pair of electron, and it fails to explain the arrangement of the atoms in the three-dimensional space also. Understand? So this is all about the drawbacks. So the next one is valence bond theory. Remember VSEPR theory, it doesn't tell us about overlapping of the atomic orbital. So to overcome that drawback, valence bond theory is introduced. Okay? So this valence VBT, that is valence bond theory. Okay, so students, this valence bond theory is tells about the formation of covalent bonds. This valence bond theory especially tells about what? Formation of covalent bonds. Okay, so let's see what are the salient features, the postulates are salient features of VBT. Very important for 3 marks. Okay. So the first one is the covalent bond is formed by overlapping of atomic orbitals. First one. Okay. Next one. Greater the overlapping, stronger is the bond. Stronger is the bond. Greater the overlapping, stronger is the bond. Okay. Next, when covalent bond is formed, molecule attain minimum energy and become stable. Another one, right? Okay. The extent of overlapping is in the order PP overlapping is greater than SP overlapping greater than SS overlapping. This PP bond is sigma bond is stronger than this SP overlapping actually, not bond. PP overlapping is greater than SP overlapping greater than SS overlapping. Next, the last point, overlapping along axis is more stronger than this drop greater is stronger than overlapping along sideways. Okay, so these are the postulates. What are those? The first one, the covalent bond is formed by overlapping of the atomic orbitals. Means this is the one atomic orbital. So these are the two atomic orbitals. Assume, okay, they overlap with each other. So when they overlap with each other, then they form a covalent bond. Okay, like this. So this is one axis. This is one axis. So they completely overlap. Means they form strong bond. Understand? So here listen, if I tell this. So this is one orbital, this is another orbital. So they overlap with each other. So this is the surface area or more the axis. Okay, remember that. So here they form a double bond. Sorry, single bond or any bond, double or single, later I will explain. So they form what? When they overlap with each other, they form a bond. So this is called what? Orbital overlapping. Atomic orbitals means what? SPDF orbitals. Those orbitals, they are going to overlap with each other. Especially, and remember, so while they are overlapping, one orbital is having the electron of, means both orbitals are of opposite spin. For example, here one s orbital is there, here one s orbital is there. So this orbital will be like this. If they are in the opposite spin, then only the overlapping takes place like this. The atomic orbitals having the electrons with opposite spin, they get overlap. Understand? So next, greater the overlapping, stronger is the bond. Means listen here. This is the overlapping surface here. So here the bond is here. They are not at all overlapping. They are exactly touching. So then what is forming here? Here the length is more. Then we easily break this. So if it is like this, the overlapping is some extent more. Then the length becomes less. Then it requires more energy compared to this. So it is completely overlapped like this. Then the bond distance become very small. Then it takes more energy to break this. Means greater the overlapping, stronger is the bond. So this is the surface, means if it is overlapped at this point, then we can easily break the bond. Means the bond is not strong. If it is completely overlapping is more, it covers complete orbital, then the bond distance is less, so it requires more energy to break the bond. Understand? That is the one concept. Next, when the covalent bond is formed, molecule attain minimum energy and become stable. Means, for example, any molecule is there, like lithium plus lithium is there, and Cl is there. So here what happens means, of course, the covalent bond is going to be formed. So this is s orbital, this is p orbital. Okay, here one electron is there, here five electrons are there. Among them, only one electron is going to be over. So when they form Li cell, then what happens? This is s orbital, this is p orbital. So students, initially if it is lithium, that is unstable, if it is Cl, that is unstable. When it becomes lithium chloride, then it becomes stable. This is gaseous in form. This is of course metal. LiCl is salt. Are you getting? So when the covalent bond is formed, the molecule loses its high energy. When the molecule is at lower energy, means that is stable. When any species is at a lower energy, then it is stable. If it is higher energy, then it is unstable. Means after the formation of the covalent bond, they are satisfied with their valency. Okay, that's why they loses their extra energy and become stable. Next, the extent of overlapping is in the order. Means, so two p orbitals overlap takes place means, of course, the overlapping is more. Why? So listen. So if we take the s orbital, that is spherical. Instead of that, if we take p orbital, that is dumbbell. Means here compared to this sphere, the surface of this p orbital is more for bonding. Availability of surface for the overlapping is more in p orbital compared to this s orbital. The size depends, size matters. Okay, so here more surface area, here the second one, greater the overlapping, stronger is the bond. Means if the greater surface area is available for overlapping, of course listen, if s orbital is there, if s orbital maximum overlap only at this position. But p orbital is not like that. It may be completely overlapped like this, or it may be completely overlapped one above. There is a possibility, means the p orbital provides greater surface area for bond formation. So that's why the pp overlapping is more compared to sp, because s orbital is spherical, p orbital is dumbbell, compared to s, this size is more, and they provide greater surface area for the overlapping. And here s is overlapping. This is the part. And next, overlapping along axis is stronger than overlapping along sideways. So what is this axis? What is this sideways overlapping? Why this axis overlapping is stronger? Why not the sideways overlapping? I will explain now. The types. Okay. So this is all about the postulates important for 3 marks. Remember. Now, now it is types of overlapping. So students, two types is there. One is head-on or axis overlapping. Head-on or axis overlapping. So this is called as the sigma bond formation. If axis overlapping takes place, that bond is said to be a sigma bond. And remember the words, if the single bond is there, that is sigma. If double bonds is there, that is pi sigma. If triple bond is there, pi sigma pi. I already explained this on. So why it is like that? So remember, before in the structure of atom, I already explained. If single bond is there, that is alone sigma. Double bond means pi sigma. Triple bond means pi sigma pi. Understand? Okay. So that's what we are going to study in this. Why it is called as a sigma bond, why it is called as a pi bond. So students, if axis overlapping takes place, then it is said to be a sigma bond. Okay? So right here, one bond, two atomic orbitals overlap end to end along axis to form bond. So that bond is called as sigma bond. You write in words. Sigma bond. So the two atomic orbitals overlap end to end along axis to form bond. The bond is said to be called as sigma bond. Remember this. So students, difference between sigma and pi bond is important for 2 months. But remember, initially I explained types of overlapping in the head-on axis, head-on or axis overlapping. Later on, the one is sideways overlapping. So I will write the types here. One is head-on overlapping. Another one is sideways overlapping. Two types. So initially I will explain what head-on. So students, in this again types is there. One is SS overlapping. Another one is SP overlapping. The next one is PP overlapping. Especially in head-on overlapping. So this is SS sigma bond. This is SP sigma bond. This is PP sigma bond. Okay. So now listen here. What we are going to study? How the overlapping takes place. So students, here the first one is SS overlapping. Okay, so we are going to take the S orbital. S orbital shape is spherical. Okay, so another S orbital. S orbital and S orbital. Okay, so then they form overlapping orbitals like this. They form a sigma bond. This is what? SS sigma bond. So once the bond is formed, the shape of the molecule becomes like this. Why? This is the, if we just remove this, this is the shape of the molecule. Are you getting? Because overlapping takes place here. I should write here. So here S orbital one electron is there, here is there, here they are arranged in an opposite spin. Okay, so I'll completely represent this. They are in opposite spin. This is SS sigma bond. And so same molecule, if I write it again, here they are atom. So bond is formed, become molecule. So when it is molecule, the shape of the molecule is like this. Are you getting? This is how the SS overlapping takes place. Axis. Of course, it is spherical shape. It doesn't have any axis. So greater the extent of overlapping, greater is the bond formation. Are you getting? So this is one type of formation of bond. Which type of bond? Yes, is overlapping. That is sigma. So students, one electron is, of course, this is hydrogen atom. This is also hydrogen atom. This is H2 molecule. In the right line. This is a formation of an H2 molecule. SS overlapping. Next. Second one is SP overlap. So students, I'll take the example of HF molecule. Okay? Listen. The hydrogen atom has spherical shape. Fluorine atom has tumbler shape. Because if you write the configuration, this is 1s1, this is 1s2, 2s2, 2p5. So here p orbital, here s orbital. This is s, this is p. So then what happens? Overlapping takes place. Means these two gets overlapped. This is s orbital and this one is p orbital. The electrons are in opposite spin. Here is one electron, here is one electron. They are in the opposite spin. This is what? S, P, sigma bond. Okay, so students, now how the structure becomes? So listen, this loop is smaller in size, like this. This is how the orbital overlapping takes place. They become smaller in size. One loop where the electron is not present. Understand? So this is not necessary for you people. Just remember this. Formation of a sigma bond, that is sp sigma bond, because this is HF molecule. Are you getting? So in both these three cases, what is happening? This is the axis. This is the axis. Okay, this is one end of this p orbital. This is of course spherical, means there is no end. So end to end axis overlap. Are you getting? So listen, if s orbital is here, so listen here, HF is there, okay, HCl is there, HBr is there. If we consider the bond angle, this is greater than size, means overlapping is less. So HF is stronger bond than HCl than HBr. Why? I'll show you. So listen, if we consider HF, so this is H, this one is F, means overlapping is greater. Next, if you consider this is H, this is H, this is M, means here only somewhat overlapping takes place. That's it. So if you consider HBr, this is S, this is only small overlapping, that is HBr. Means greater the actual overlapping, when greater the surface area covered in overlapping, stronger is the bond. So HF is stronger than HCl, stronger than HBr in the bond I am telling. Understand? So the next one is third one, that is PP overlapping. Means F2 molecule. So students, both are F2 molecule. You know F2 molecule means the electron is present in p orbital, the valence electron. So I'll take one F here plus another F here. This is having electron here, this is having electron here. After the bond formation, they become like this. This is PP sigma bond. Are you getting? So this is what, so we will write it clearly. One electron is here. That is PP sigma. This is P orbital, this is P orbital. So students remember, in the sigma bond formation, there is a possibility of formation of 3 sigma bonds. One is by overlapping with SS orbital, by overlapping with sp, and by overlapping with pp. So this is what the add-on overlapping or axial overlapping means. Valence bond theory means it tells about overlapping of the atomic orbitals. That overlapping of atomic orbitals takes place in 2 ways. One is add-on overlapping, another one is sideways overlapping. What is add-on overlapping is, so when the 2 atomic orbitals overlap end to end along the axis, that is what add-on overlapping or axis overlapping to form a bond. When this type of overlapping takes place, that bond is called as a sigma bond. So in that sigma bond, 3 types is there. SS sigma bond, SP sigma bond, PP sigma bond. That is depends on what? Overlapping of the atomic orbitals. If 2 s orbitals overlapping along their axis are end to end, they form SS sigma bond. And 1 s orbital, 1 p orbital overlap with each other end to end or along axis, they form sp sigma bond. Then 2 orbitals overlap end to end or an axis, they form pp sigma bond. And this is the shape of the sigma bonds of SS, sp and pp. So the next comes is what? Sideways overlapping. This is also called as pi bond. So students, how the pi bond overlapping takes place? 2 atomic orbitals overlap with each other in sideways. Both are correct. What do you take? Overlap with each other in sideways to form a bond called as pi bond. Pi bond. Okay, so students, in this pi bond, only one type is there, that is PP pi bond. That is PP overlapping p pi bond. Means in the sigma bond, three types is there: SS, SP, PP. Okay, in pi bond only one type is there, that is PP. Means S orbital cannot form pi bond, only P orbital can form pi bond. Okay, so the next one here, listen. So students, you know the P orbital I already know. So this is XYZ plane. So this is X, this is Y, this is Z. That's X, Y, Z. X, Y, Z. So this is Px orbital means the orbitals are like this. Py means they are like this. And Pz means they are like this. Remember students, always the Pz orbitals is considered as the main axis. It forms sigma bond. Remember, in Px, Py, Pz, the Pz axis is considered as a main axis, means horizontal axis. Means overlapping of Pz orbitals always form sigma 1, and only X and Y are involved in the formation of a pi bond. Are you getting? So now, assume this is X orbital. So here two orbitals are there. One is Px orbital, another is also Px orbital. So Px orbitals are here. Okay. So here the sideways overlapping takes place. Means this over orbital. So overlap sideways with this orbital. Sideways overlapping. Okay, so here any atom is there. Assume for example, for sideways overlapping, I'll explain later. I'll explain. So here, how the bond will take place means, if this is the two bonds, the bond is formed by above the plane and the below the plane, not at the center. This is how the bond takes place. This is what PP pi bond. So students remember, in the axial overlapping like this, the greater the surface area covered, here is more. But in the sideways here, they are covering only smaller area. Means compared to sigma bond and the pi bond, sigma bond is the stronger bond, pi bond is the weaker bond. Why? Because here the extent of overlapping is more, here the extent of overlapping is less. So this is the one major difference. So first one. So listen, axial overlapping, sigma bond, sideways overlapping, pi bond. So sigma bond is a strong one, pi bond is a weak. Sigma bond has extent of more extent of overlapping. This one is having less extent of overlapping. This bond, sigma bond, has types SS, SP and PP, and P bond doesn't have any types. Sigma bond cannot be converted into pi bond, but pi bond can be converted into sigma bond. These are the difference. Later I will write the difference. Just remember, this is Px, Py and Px, Px orbital, they form PP pi bond. So this is what for X orbital. So if you consider Y similarly, Y orbital is in this form, means like this. So this is Py, Py. Then this is how the bonding takes place. This is PP pi bond. Remember students, whenever the orbitals gets overlap, S overlap with S, means 1s with 1s, not 1s with 2s. Okay? And remember, Px, when it overlaps with Py, then only they have the capacity to form pi bond. Px cannot be overlapped with Py. Why? So listen, this is the Px orbital and this one is the py orbital. Listen, they are not in the plane. If we make the bond may be like this. Of course, there is no possibility of formation of a pi bond here. If one is px, another one is py, there is no formation of a bond because they are not present in the same plane. Are you getting? Means px always bond with px or overlap with px, py always overlap with py, and pz always overlap with pz. So remember, so this is px, py, I said. Assume if instead of py, pz is like that. How the overlapping takes place? It cannot be possible. It may be like this. This is impossible. They cannot form overlapping. Means the orbitals which are in the same plane, or x plane, or y plane, or z plane, they overlap with each other to form pi bonds. Are you getting? So, and also in the pi bond, only one type is there, that is pp pi bond. So, s orbital cannot form pi bond. They form only sigma bond. But p orbital, they form sigma as well as pi bond. Okay. So, based on this, I'll explain structure of O2 molecule. So remember students, here I wrote like this, means pi bond. So don't consider this is one bond, this is one bond. Together this will form a single bond. Means one is the above plane, another one is the below plane. So I just explain, then you came to understand. So O2 molecule, that is oxygen is their configuration 1s2, 2s2, 2p4. Correct? So because atomic number of oxygen is 8. So if you write the configuration here, it will be like this. Means two orbitals are having what? Only one electron pair. Means this is assumed px, py, pz. Px, py and pz. Remember student, if nothing is there, only one electron is there, that is pz orbital. If two or more is there, px, py, pz. Later I will explain the possibilities. So listen here, one is py orbital. Means I'll write here. So from one oxygen atom 1, so another oxygen atom also same. Px, Py, Pz. So now, one Py of this oxygen, one Py of this oxygen overlap like this. So they form this type of bonds. So that is P bond. Means if I take oxygen atom here, this is p orbital, another oxygen atom, this is p orbital. Which orbital? pz, here, this one, pz orbital. So another one is py, like how? Like this. So students remember, here of course the axial overlapping takes place. Means they form O single bond A. So another one is sideways overlapping. This is py, this is py. So here one is like above, one is like below. These together form a pi bond. This is how the overlapping in the pi bond takes place. One will form a sigma bond, pz, I said already. They are going what? Axial overlapping, that is sigma bond. Here they are going sideways overlapping. Means above the plane, below the plane. They together form one bond. That is pi bond. Understand? So this is all about what? The formation of the pi bond. Sidewise overlap. So now the difference between sigma and pi bond. Now it is difference between sigma and the pi. Okay. Sigma 1 is always pi. So the students' first one is the sigma bond is formed by axial overlapping of atomic orbitals. Okay, so this pi bond is formed by sideways overlapping of atomic orbitals. Okay, next sigma bond has types SS, SP and P. Pi bond is of only one type, that is PP. Next, further, bond is, this is a stronger bond, this is weak bond. This is completely stronger, this one is weak. Okay, next fourth one. This one exists alone as well as with pi bond. Okay, alone remember. Next, this one always with sigma bond only. Means pi bond is always along with sigma bond, but the sigma bond can be exist alone or along with pi bond. Means if one bond is there, that is always sigma bond. Single bond exists, but single pi bond, alone pi bond does not exist. So this is a single bond sigma I told. This is sigma pi. So this is pi sigma pi. So the pi bond is always present along with the sigma bond, but the sigma bond is present alone. Okay. So dear students, the free rotation is possible. Here, free rotation is impossible. Why? So listen here. If this is the bond, single bond, these are the atoms. We can easily rotate. Are you getting? We can easily rotate along this single bond. If another bond is there, two bonds, here the atoms are there, it can be twisted like this. It cannot be rotated freely. But in the single bond, of course, it is easily rotated. Rotation is possible in the sigma bond. Rotation is impossible in the pi bond because they get twisted. Are you observing? So the free rotation is possible, here free rotation is impossible. So this is how the difference between sigma and pi bond important for 2 marks. Okay. So in the remaining we will discuss in the next class. Thank you.